Hello all. I hope you're all doing good. I'm Shruti Sudhir. I'm a data science and business analytics intern at the Sparks Foundation. This is my second task as a part of this internship, and this task is to make predictions using unsupervised machine learning. And for this task, I have considered the dataset, which is Iris dataset, and I have used Python to perform this task. And so initially I'm importing the required libraries of pandas and numpy, and then I've downloaded the required dataset into my system. Now I'm reading it, and I also created the data frame, pandas data frame, and these are the first 5 rows in the data frame. And then as you can see, there is a ID here, and this is also the pandas data frame default ID. So to prevent confusion, I'm removing this ID from this data frame. So after removing, I go on to finding out the number of rows and columns in this data frame. There are 150 rows and 5 columns. And then I move on to find the data types of each column. And as you can see here, there are 4 continuous variables or features, and there is one object or categorical variable. And these 4 features are the predictor variables using which I have to perform the clustering based on the optimum number of clusters that is given to the algorithm that is being used. And so species, this categorical variable is going to indicate which kind of category or cluster does that particular data points belong to. So after that, I have moved on to data cleaning, wherein initially I have checked for the existence of missing values. There were no missing values in the data frame. And then I moved on to removing or dropping the duplicate rows from the data frame. And after that, I find the shape to be of 147 rows and 5 columns, indicating that there were 3 duplicate rows in the data frame which are now removed. So after the data cleaning, I move on to the data analysis part. So initially I do the univariate analysis to find out what kind of distribution or what kind of change is there in the different variables. So firstly, I use the dot describe function, which gives me the descriptive statistical summary of all the continuous features in my data frame. We can see the mean, standard deviation, and median of each of the variables. And then after this, so there is one column that hasn't, be- uh, given the descriptive statistical measures, which is the species, since species is a categorical column. And another point to note is that a machine cannot interpret features or variables which are in the form of strings. So it can only interpret variables which are in the form of numbers, which are in the form of digits. So to do that, I do something which is known as label encoding. Label encoding is wherein I change the labels into some numbers to and make it continuous. So for this, I use the label encoder, which is a part of sklearn.preprocessing library. So I create an object, and then I fit the data, the species column of the data frame. And then after encoding, you can see that the strings are now removed, and you can see that there are digits or numbers in places of those strings. To understand more regarding the data, I move on to data visualization. And for data visualization, I use the libraries of Seaborn and Matplotlib. So initially, I go on to visualize the species column, which is our main categorical output. So as you can see, there are 3 categories, and with slight variations in the count. To find out the exact count, I also use the dot value counts function. So I can see that of category 1, there are 50 rows. Of category 2, there are 49 rows. And of category 0, there are 48 rows. And then I move on to multivariate analysis to find out how each variables are being dependent or are changing with with accordance to the remaining variables. So for this, I create a heat map wherein the correlation between the different continuous features are considered. So since our main aim is to find out how species is being uh, varied with respect to the different other continuous predictor variables, we focus on to this last row. So closer to 1, the values are 0.95 and 0.96. So we can infer that petal in centimeter and petal width centimeter have more effect on the species variable relative to the remaining two columns. So let us just keep this in mind when we build the model. And then I go on to one more visualization, which is SNS.pair plot. So the pair plot also helps me understand how the species is changing with respect to the predictor variables. And we can note that the species with respect to petal in centimeter and petal width centimeter are more clearly distinguished or differentiated relative to the remaining two variables. So initially considering all the four predictor variables for model building or for learning, I take all. So for that I create a data frame consisting of only the predictor variables, and then I use the k-means algorithm, which is a unsupervised machine learning algorithm. So the first step in this is to find out the optimum number of clusters into which the data points are to be categorized into. So for this, I firstly proceed by calculating something which is known as the WCSS, where WCSS stands for within cluster sum of square. It can be described as the sum of squared distance between each point and the centroid in a cluster. So what it does is it finds out the distance between each data point to the centroid of the cluster, and whichever is a less value, it assigns that particular data point to that particular distance which is of a less value, which means it has more relevance to be in that particular cluster. So after finding out the WCSS values, I plot something which is known as the elbow curve. This is a very famous method, or also known as the elbow method, which is used to find out the optimum number of clusters. You can see here it forms the shape of an elbow, and if we see carefully, it is at a value between 2 and 4, approximately at value 3, that the elbow is being formed, right? So the optimum value for k can be concluded as 3 as per this graph. So with an increase in the number of clusters like 4, 6, 8, we can see that the WCSS values are also decreasing a lot. And after 3, the drop in WCSS is also minimal when compared to before 3. So 3 would be the optimum number of clusters. So based on this 3, I move on to build a model using k-means. After building, I fit the model onto the test data, and then I make predictions. And in this case, I have not clearly, split the data into train and test. The complete data, since it's unsupervised machine learning, I have taken the complete data and I'm splitting it into clusters. And these are the clusters that are formed. And to visualize those clusters, I'm using Matplotlib and a scatter plot. So as we can see, these are the clusters that are formed, and the red marks that you see here are the centroids of each cluster. So when any other data point comes, according to the k-means algorithm, the distance from these three centroids are calculated, and based on that distance, the new data point would be assigned to a particular cluster. So for unsupervised machine learning algorithm, there are various metrics that can be used. In this case, I have used the metric of adjusted RAND score. So we already know the actual cluster values, right? So I can use those actual values along with the predictions I made to find out the uh, or to evaluate the model that I have built. So the value that is obtained is 0.73651, and the adjusted RAND index, more close it is to 1, more good is the model. So this is okay. This is a good model as it is close to 1, as this metric is close to 1. And now, based on the correlation that we have seen in pair plot and also in the heat map, based on that, I'm considering only these two as a predictor values, and I'm removing the remaining values from the data frame. After this, I fit the model, the same k-means algorithm, and I make predictions. And when I use the same metric, which is the adjusted RAND score, and now when I check, I obtain a value of 0.88225, which is more near to 1 when compared to the previous value of 0.7365. So when I only consider these two as predictor values, I'm getting a better model. So this is what I have done. This is the analysis, and this is the prediction I have done using unsupervised machine learning algorithm of k-means. I hope to get your valuable comments down below. Thank you for listening to me.